Okay, so, alright, what's going on? So I'm going to discuss basically the strategy to solve this. So surrounded regions on LeetCode. So for this problem, it's an interesting problem. So I mean, you're given this two-dimensional board that contains X's and O's, and you basically want to capture all the O's that are surrounded by X's. So like this O here, or these three O's, are completely surrounded by X's. If you look, basically you only look horizontally, so I would look to the left, to the right, oh there's an X to the left and the right. And in this O, I look vertically, I look below it, oh there's an X. And if I look above, yeah, it's connected to an O that's then surrounded by an X up here. So these are three kind of like connected O's that are surrounded by X's. Now this O here is not surrounded by X's because it's on the border. There's no X below it, so it doesn't suffice being part of a connected component that is surrounded by X's. So this one will not be flipped. So you'll flip all these to X's, and this one will remain as an O, and you can see that in this example. Now, there's one important edge case though, which I will try to draw here. So one important edge case is basically going to be, let's say you have X, 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 I guess, X, oops, O, and X. And then let's say you have an O here, I don't know, you have an X here, maybe you have an O here, maybe you have an X here. Now, in this case, these connected O's are not going to change the X's at all. So this will remain the same. This doesn't change because they're connected to an O that is not surrounded by X's. So that's the main thing. So if the O's are connected together, but they're not connected to but if they're connected to an O that's not surrounded by X's, you're done. But this is not a connected component that's surrounded by X's. You need an X here for this to be the case. If it was like this, then you would change all these to X's. Now, that's the main thing. So the strategy for solving this is, so you have this here, and then you convert it to this here, and then you go down here. So this is the code. So one way to do this is a DFS search, where basically, well, I'll look at my code while I go through it, discussing it. So here I'm just getting the length of the board. So like n represents the number of rows. So like this has 4 rows. And if this equals 0, then like just return board, like you have an empty board. If you have no rows, here you get the number of columns. Then you basically iterate through the 2 for loops to go through here. And what I'm searching for is along the border. So anything at the border, such as I is equal to 0, or I is equal to n minus 1, or if j is equal to 0, or j is equal to 1. So basically, these are all the possible borders. Like if anything where I is equal to 0 is a border, because that's the first row. Anything where I is equal to n minus 1 is like the last row. Anything with j equals 0 is the first column. Anything with j is the last column. And what you want to check for is the border equal to O? 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 And then what you do is you do a DFS search on this O. So then you go down here. Now the main thing you can do in this DFS search is basically, if you have the current place is an O, which when you first go down here, it will be an O, you want to convert that to an R. So the main idea is converting to the R, because later on, by changing this to some other character, this could be any character, it doesn't have to be an R, it could be anything that's not an O or an X, right? So it could be L, period, well, whatever. Probably a number, I guess. But the main point of changing this is basically is you want to change all the O's that are connected that to an O on a border. So in this example that I was doing, if I remove these, and remove this, remove this, remove this, remove this, and then I go back to this and do the O's here, this example would become X, 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 and I chose R, R, X, R, X, 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 and then the key here is that when you go through, when you're only going to flip O's to X's after you do complete the DFS search. So it's not going to convert these to X's, and then you just convert these back to O's. So that's what it does here. So it does a DFS search. You get the length, and you basically check if I is greater than 0. You check, oh, is this equal to O? Is there something basically vertically above it? Is there something vertically below it that's equal to an O? Is there something horizontally to the left or horizontally to the right that's equal to O? So you basically just follow the O path, doing a DFS search through it, searching through the breadth. And then you come back up here and you do for I in range of N and for J in range of M. And here you just change everything that's an O to an X. And then while you're doing that, if you come to something that's equal to R, just change it to an O. And that will give you your answer. And I mean, I've already submitted this and it works. But hopefully that helps with explaining this, or hopefully that helps by explaining this. I mean, this is like it's like a interesting problem. I believe there's another problem similar to this, which was like I forgot the name of it right now, but there's like twin force something. Also, this problem is like related to union find. You could use a union find as well methodology. I guess because you have like these connected components, and you union them together and merge and stuff. But the DFS works very simply, so that's what I did here. But yeah, it's a very good problem though. So yeah, okay.